Today's topic, a radial wave function. Today I will discuss the very important topic of the atomic structure, which is known as radial wave function. The wave function of the electron can be expressed as in Cartesian coordinate as well as in polar coordinate. The wave function can be expressed in Cartesian coordinate as phi is a function of x, y, z. This is the position coordinate. Whereas in polar coordinate, the wave function can be expressed as psi r theta phi. Psi is a function of r theta phi instead of x, y and z. Now the function of psi is a function of r theta phi equal to the function of r. Capital R is a function of r, this is the distance, and the angle theta and phi. Here the two parts are included. One is radial part and another is angular part. Now what is the radial part? The RR, this part is basically radial part, that is radial part is depend on the radius, whereas the angular part, which is expressed as YLM, and it is depend on angle of theta and phi, and this YLM theta phi is the angular part, and this is the YLM theta phi is the angular wave function, and this is the RNL is the function of r, small r. This is a function of radial wave function. So the radial part of the wave function is determined by the distance, whereas the angular part of the wave function is determined by the angle of theta and phi. Besides, the radial wave function is depend on principal quantum number as well as azimuthal quantum number, whereas the angular wave function is determined by azimuthal quantum number and magnetic quantum number. It is remembered to that the wave function of an electron in an atom, so-called atomic orbital, which is determined by basically three quantum number, which is n, l and m. Now we have find out the normalized wave function of the 1s, 2s, 2pz atomic orbital. In case of 1s atomic orbital, what is the n, l and m value? Is the 1, 0, 0. The radial wave function, this is the r in l r, this is a radial wave function. What is the value of radial wave function of 1s atomic orbital? In 1s atomic orbital, the radial wave function is 2, 1 by a0, 3 by 2 e to the power minus r by a0. And what is the value of angular wave function of 1s atomic orbital? 1 by 4/5 to the power half. Whereas in case of 2s orbital, what is the value of NLM? Is a 2, 0, 0. And what is the value of radial wave function? 1 by 2 a0, 3 by 2 to the power 3 by 2 into 2 minus r by a0 into e to the power minus r by 20. And what is the value of angular wave function? The same value, 1 by 4/5 to the power half. Now in case of 2pz atomic orbital, what is the value of NLM? 2, 1, 0, and radial wave function is 1 by root 3 r by 2 a0 to the power 3 by 2 r by a0 into e to the power minus r by 2 a0, and angular wave function is 3 by 4/5 half to the power half cos theta. Today I will mainly discuss the radial wave function. Now I will discuss the the curve is obtained, how the curve is obtained for 1s, 2s and 2pz atomic orbital. So what is the curve? The curve is basically the radial wave function against the distance, that is the r. Now we constructing the curve for 1s, 2s and 2pz atomic orbital. First of all, in case of 1s atomic orbital, mainly focused on radial wave function. So in case of 1s atomic orbital, the radial wave function is given by 1 by a0 to the power 3 by 2 e to the power minus r by a0. So in case of 1s orbital, the psi 1s, that is psi 100, that is psi nlm, that is psi nlm, that is psi 1, that is the function of radial wave function, that is rnl, r, that means n value is 1, 10, and ylm means y 00, that is lm, theta and phi. This is the radial function and this is the angular. Today I only discuss only radial wave function, and so the value of radial wave function is only radial wave function is 1 by 2 into 1 by a0 to the power 3 by 2 e to the power minus r by a0. This is the 1s atomic orbital, the radial wave function, psi 1s. Now we have plotting against radial wave function, that means r 10 r versus r. Then exponential curve is obtained because the radial wave function is depend on the distance, and the expression, from the expression we have seen that psi 1s, that means r10, r is a function of r, distance is 1 by a0 to the power 3 by 2 e to the power minus r by a0. That is term is constant, k1 e to the power minus r by a0. So exponential curve is obtained, and so the curve starting this point and this is a decay. Here there is no node is obtained because in case of 1s atomic orbital, the node is n minus l minus 1, that is 1 minus 0 minus 1, that is 0. So there is no node is obtained in case of 1s atomic orbital when we have plotted the radial wave function against r. Now we constructing the radial wave function curve for 2s and 4s and also 3p atomic orbital. Now the radial wave function curve for 2s atomic orbital. First of all, node is calculated. When we constructing the curve of radial wave function of 2s atomic orbital, firstly calculate the number of node. In case of 2s atomic orbital, the number of node is 2 minus 0 minus 1, that is 1 node is obtained. In case of s orbital, the curve is basically exponential decay. So the curve cannot start from the origin. And this is r, this is the 2 0 and this is the r. So the curve cannot start from the origin in case of s orbital, but in case of p, d and f orbital the curve starts from the origin in case of radial wave function curve. Okay, this is very important information. Now in case of 2s atomic orbital, so one node is obtained, so curve is starting this point, this curve not starting from the origin, so exponential decay curve is obtained from this expression. So the curve is starting this point and one node is obtained is here. So this is a positive and this is a negative and this is a node. This curve is obtained in case of 2s atomic orbital. Okay. Now we have drawn the curve of the radial wave function in case of p atomic orbital. That is 3p atomic orbital. Now this is a 3p orbital. First of all, node is calculated. Now this is the n minus l minus 1, that is 3 minus 0, that is 3 minus 1 minus 1, because in case of p atomic orbital the l value is 1. And now this is the 1, the node is 1 in case of 3p orbital. Okay, so this is the, here is the r, n value is 3 and l value is 1, this is the r and this is the r. This is the distance and this is the radial wave function. So in case of p atomic orbital the curve will start from the origin. Okay, the curve will start from the origin and one node is obtained, and this is here, this is the plot, the node is obtained and this is the minus, and this is the radial wave function curve for 3p atomic orbital. So it is very important information when we draw the curve for radial wave function. Firstly, we can calculate it, the number of nodes, and secondly, the curve is starting from the origin in case of p, d and f atomic orbital, and the curve cannot start from the origin in case of s atomic orbital. Now we will discuss the radial probability distribution or radial density. Radial probability distribution or radial density. Study the radial probability distribution or radial density. This is very important. Considering an atom to be made of thin annular shell of thickness dr, and considering such shell at a distance r from the nucleus. Now, what is the value of dV? This volume. What is the value of dV? So the dV equal to 4 pi 3 pi plus dr. This part is dr and this part is r. So pi plus dr tara whole cube minus 4 by 3 pi r cube, and then the dV is obtained. That means subtracting from this value to this value, then the dV, the small volume, is obtained in a range at the dr. From solving the equation, we have seen that 4 pi r square dr plus 4 pi r dr square plus 4 by 3 pi dr cube. The dr is very small, and that's why dr square and dr cube can be neglected. So the value of dV equal to 4 pi r square dr. Now the radial probability distribution is radial wave function square, that is r square into dV. The radial probability distribution is the square of radial wave function into dV. Now r square, the value of dV is 4 pi r square dr. So this term r square 4 pi r square dr is known as radial probability distribution. It is the total probability. The radial probability distribution is the total probability of finding the electron in a spherical shape at a distance r from the nucleus. Here the function r square 4 pi r square dr is called radial distribution function. Radial distribution function. Here the following curve is very important, and these things are very important for the drawing of the radial distribution curve. What is the points, important points which are responsible for the drawing of the radial probability distribution? Firstly, the curve, first point, the curve should start from the origin in any orbital. For 1s, 2s, p, d, p, for any orbital, the curve should start from the origin. And secondly, the number of nodes is calculated. And third point is very important, radial distribution curve cannot have negative value because this is the probability. So the term is square. So it have no negative value. All the value is positive. Here we have plot the radial probability distribution of 1s atomic orbital. In case of 1s atomic orbital, firstly node is calculated, the node is 0. And so the curve is start from the origin and there is no node, and this is the curve, and the maximum probability of finding the electron is maximum this point. This is called Bohr radius and the value is 0.529. The distance from the nucleus where there is a maximum probability of finding the electron corresponding to the radius is called atomic orbital. Again we prove that the distance for the maximum probability of finding the electron in orbital increases with the value of principal quantum number. In case of 2s atomic orbital, we have seen that only one node is obtained and the curve will start from the origin, and so the maximum probability of finding the electron is maximum this point, the maximum probability of finding the electron. From the radial distribution curve for 1s and 2s orbital, it is evident that at a distance close to the nucleus, the probability of finding the electron in 1s orbital is higher than that of the 2s orbital. In case of 1s orbital, the probability of finding the electron near the nucleus is maximum. So we conclude that the penetrating power of the 1s atomic orbital is greater in case of the 2s atomic orbital. And similarly, in case of 3s atomic orbital, the node is 2 because 3 minus 0 minus 1, and the probability of finding the electron is maximum in case of 3s atomic orbital is here, this point, the probability of finding the maximum electron density. If we plot for the 3s, 3p and 3d atomic orbital, we have seen that the probability of finding the electron is maximum near to the nucleus in case of 3s orbital is greater than that of the 3p and 3d atomic orbital. From this curve, it is evident that the penetrating power of the 3s is greater than that of the 3p and 3d atomic orbital. So in this topic, the radial probability distribution curve and radial wave function curve is very important. Okay, if any problem you can mention in the comment box. Thank you.